So finally, you have learned the basics of MATLAB, how we can perform several kind of operations in it. Now it's time to integrate the machine learning with MATLAB. We will be performing an example here. So that specific problem is related to the body fat estimate. Basically, this is based on a data set on neural network will be trained. Training and validation error will be minimized. So we will see how our neural networks perform on the prediction of uh, body fat estimation model. This model is based on the 13 parameters of human body, which age, weight, height, neck circumstances, etc., thighs, knees, and it has 252 examples in it. It is not a very big data set. The data set is the power in model. Have a huge data set and possibility that our neural networks or any kind of model which training can perform better on this one. So this is a very basic example of integration of machine learning with MATLAB. So we have already learned how we can several perform several variables. How we can plot several type of graphs in it. How we can change the properties of graphs, and we are pretty much familiar with the usage of MATLAB in regard. So now let's dive into the machine learning application. Here I have opened my MATLAB environment. As you can see, I have inserted several comments. Starts with the percentage sign, and at the starts, as usual, I have inserted clear screen, clear all command, and close all command. So let me revise these commands for you. CLC basically clears all the outputs in command window. Close all clears all the variables which are available in workspace. Pretty sure that you are familiar with those. If you do not remember them, I would recommend you to watch the start first 5 to 10 minutes of the this video. You will learn what is we are all doing. And the close all command closes all the open windows. Those can be here, those can be any kind of MATLAB. So let's start. To start this project, we first of all we need to load our data set. So I am defining variable x and t as the input parameters. One is input. So the name of our data set is body and body fat underscore data set. So I'm inserting semicolon at of this. So I will be frequently running my code to check for any kind of errors. If you are trying this code with me, you don't need to run it every time. You can simply download this file from my GitHub repository, which is given in the description of this link, and you can download that and open it in your MATLAB environment. You can change it as per your choice. So here I have uploaded the dataset into x and t variable. So let's see what is the size of x and t. These are the parameters. T is the basically those 13 parameters from which this data set has been collected, and x is the number of examples. Those examples can be humans. Let's suppose that we have 100 male and 100 female and 52 children's. Those basically these are called we call it example in the machine learning, and the t is those parameter from where those measurement has been taken. So if you remember in the matrix operation, I performed size command. So we will be again doing that. Size is used for to determine the size of any kind of variable, array, matrix, or any operation in the MATLAB. So let me rerun it. So in my command window, it is giving me 13 cross 252. As I told you, MATLAB is the matrix laboratory. Here are 13 examples which are based on the 13 parameters which are based on the 252 samples. So this data set is 13 cross 2 data set. Okay, now if we check the size of t, and we can see that this size of t is 1 cross 250. So the t is of examples. So let us uh, plot a simple fit on this data set. On this data set. So for that purpose, I am physical basic command of the MATLAB demo set demo random string set demo rand. It has specific value 49121838. Just simply have to copy this and run this code. Let's see what it gives us. So it should plot. Here is an error in it. So let me resolve it. Set demo string. Okay. So here is a typo. Let me correct it. It happens a lot with me. I do a lot of typo mistakes. No worries. So after plotting this, so after locating this fit on the our data set, we just simply need to initialize the whenever you will be working on the neural networks, you will have to simply put this command and this fit net 15. I will discuss later on what is the of this 15. So let's see the output of this command. This will initialize the neural networks and a window will pop up in which we will be uh, observing our neural network. Sorry, I missed a command. View, comma, net. With applying above command, we have loaded our neural network set, and in the command window, we can see that it has displayed us its attributes, and which are based on the 13 cross 252 X set. And it has one input layers, two hidden layers, and one output layer. So when I will visualize this neural network by using the command of uh, uh, view net, so we can see that will show us one input layer, two hidden layers, and one output layers. And the weight of those elements will be 15, which we have adjusted here. If I write 150 here, it will be accordingly. You can adjust uh, and apply any kind of weight to the neural network. It is up to you how much efficiency you want. So as I am just demonstrating it here, so I am just using 15 for my convenience. So let's read on it, and we will show a neural network in our front. After that, we will be training this model. Okay, so here it is. We have our neural network, which has one input layer, two hidden layers, and one output layer. And these are the weights and biases. We have used 15 biases elements in. So now it is ready to be trained. These samples are automatically divided by the training and validation set and test set. Normally, if we have any kind of data set, we split into different folds. Mostly 70% of the data set is used for the training purposes because in machine learning examples we have to train the data, we have to train our models, what is the behavior of data, then we validate our data by observing the how this model is performing, is it performing well or is it performing bad, and after that we test on the data. So usually I prefer the 70% data set for training purposes, 15% data set for the validation purposes, and 15% data set for the test sets. So here it is by default changed into this. So let me initialize it. Network bracket train. So in this model, a built-in variable type is used, being referred as net comma char, and I will write the command train. So it will tell my model that you have to train. You can see that it is showing me the attributes of train, what kind of I can, what inputs I can input. So since I am using neural network, so I am using net comma x comma p. So we know that what is inside X. X is 13 cross 52 and T is 1 cross 252. So it will simply do various kind. When I run this, a window will pop up and we can observe different kind of behaviors on that window. So let's run it. Okay, it is might take few time, so you have to stay with me. We can visualize different performance behaviors from this. Okay, so now the training has been started. The our model ran for 9 iterations since it was based on only 252 examples, and the only 70% of those examples was being used for the training purposes. So it only took 0.2 seconds for this. So let's see what is the performance of this. Basically, this is the basic interface of neural networks, and if you click on the performance, we will observe how our model performed and what were the attributes. So here we can see that our model showed the best validation performance at 34.4082, which was during its third epoch. Epochs are basically iterations. So it means that our model ran for 9 iterations, but at the third iteration, it gave us the best performance. So let's see how was its training state. So in its training state, okay, let me open the error histogram then about it. Okay, if we talk about its training state, we can see that after passing every epoch, the value of our gradient decreased. Started from this point with the passing of every iteration, our gradient. Basically, gradient. The core purpose of gradient is decrease for the optimization problems. Since neural networks are the convex optimization, we only need to dive into the global minima. So if you do not know about what is global minima, you can watch our other video shown multiple types of what is the purpose of learning rate, what is the gradient, what is different, what are the sigmoid function and related issues. You can simply watch those videos. But for now on, you only should have one thing in your mind, that the value of gradient should decrease after every epoch, and value of the gradient should not have spikes in it. It should not jump very frequently from one point to the other point, so it can properly optimized and stuff. So if we talk about the error histogram, here we can see that the error of this, for training purposes, this error was very higher. We have not optimized our testing and validation. This is basic neural networks training tool, so it is showing us the existing, it is predicting us the existing what behavior will be for testing and what behavior will be for validation. So error was from these values in these instances. Error was higher in the medium. At the end of our model, training set error was reduced to a very uh, there was a very limited point in targets and outputs. So as I have seen this from this, we can also apply our techniques to visualize the behavior of this. So to open any kind of figure, we only have to write command, and then another command, plot perform, is used for the neural network. So plot perform parenthesis. So here we will be observing the performance of training set, how it has performed and what behavior it is showing us. So let's take it 2 to 3 seconds for training purposes. Meanwhile, I can define my test X and test Y uh, variables, so I can work on those. Okay, till its progress. Okay, The performance set is here. That is the same diagram which we extracted from the neural network training set. I was just trying to show you that you can use simple plotting techniques to plot this as well. Okay, for test x and text y, we simply need to write these lines equal to x parenthesis. Column means all columns of this data set. It will train dot test independent variables. What it is saying that test x is a variable which will take all the elements from x input and independently test them. We have trained our model. Now we are working on the training purposes. So for this, we will be repeating same er test. Okay, fine. So now let's measure its. Let's see what it gives us. So now uh, we have implemented our training data set on neural network, and in part we can see show the improved part. I want to open another figure, so I have to write the figure prompt plot regression. What will it do? It will plot the regression diagram for our model. So t comma y. It will show us what were the actual values, how our model performed on values plot. To compute the error in this, what is the training and testing, I will simply have to put is equal to t minus y. We know t was our input and this output y is our output. The value of x has been processed through this neural network and its values have been stored in y. So now we will minus these values from our datasets variable x and store them in a variable e, which I am going to show in this plot. You can see whenever I am going to call a plot, I am using the command of figure. This command opens up a new window for that figure. If I do not write this program, it will not give any kind of error, but it will replace the previous figure with the newer one. So we cannot compare our model, how much changes it has made into. So now, once again, I copy this. I am not visualizing E, I am trying to visualize error. So I will write error. So I want to change the graph type as well. So I am trying to visualize histogram for the error. So I will use this command plot error hist. What it will give us? It will give us the error for training loss, validation loss, and test for the neural network. These specific commands are designed for to visualize and plot the outputs and features of this. So this was all about the example. Um, this was only to let you know that how you can integrate your basic knowledge of MATLAB into the machine learning, how you can use your knowledge for the improved working. MATLAB is a very good tool to learn machine learning. And next module, I more signal processing techniques and tools, more signal and systems will be discussed. And at the end of that module, we will also be working on a specific project. I will try to explain it more. Hopefully, you would have liked this tutorial of mine. So, you have any queries, if you have any questions, if you want to learn a specific point with respect to the applied machine learning in MATLAB or the applied signal processing in the MATLAB, you can simply contact us, our email, you can simply comment us, or you can connect with us on the LinkedIn. All the links have been attached in the description. Thank you so much for watching with this tutorial with me.